Hi all, welcome to beiasacademy, Science and Technology Audio Notes for Prelims and Mains, Unit 6, Part 4, Chapter 2. In this chapter, we will discuss ozone layer depletion and acid rains. The topics which we are going to cover are: under ozone layer depletion, we will see the importance of ozone layer, ozone depleting substances, and the impact of ozone depletion on human beings and other life forms. Next, we'll discuss about acid rains, reasons for acid rains. Next, we'll discuss the types of acid deposition, and then finally we'll discuss about the possible impacts of acid rains on human beings, other organisms and life forms. So let's start with the first topic, that is ozone layer depletion. Ozone layer depletion is one of the most serious environmental problems faced by the planet Earth. It also leads to global warming. Ozone is a colorless gas. It does not have any color. It is colorless. It is found in the stratosphere of the Earth's upper atmosphere. It is one of the Earth atmospheric zones. Stratosphere is the Earth's atmospheric zone. This ozone is found there, which is a colorless gas. You can remember as stratospheric ozone. Okay. This layer of ozone gas in the stratosphere protects us from harmful ultraviolet radiation of the sun. This ozone in the stratosphere protects us, that is, the Earth and the other human life forms and human beings, from harmful UV radiations of the sun. How do they protect us? This ozone layer absorbs the harmful UV radiation and thus prevents these rays from entering the Earth's atmosphere. Ultraviolet radiations are high-energy electromagnetic waves emitted by the sun, which, if enters the Earth's atmosphere, can lead to various environmental issues including global warming and also a number of health-related issues for all the living organisms. UV rays, harmful UV rays, can also create or can be a cause for mutations as well. There had been a lot of research on ozone depletion from 1970s to find the possible causes that led to this problem and the effects of ozone depletion. This is being studied from 1970s. The most important reason found in the ozone layer depletion is the production and emission of chlorofluorocarbons, in short CFCs. These chlorofluorocarbons led to almost 80% of the total ozone layer depletion. How much? 80% of the ozone layer is depleted by chlorofluorocarbons or CFCs. The ozone depleting substances found to cause ozone depletion are halogens, carbon tetrachloride, hydrochlorofluorocarbons, methyl chloroform, methyl bromide, etc. I'll repeat. The ozone depleting substances are halogens, HALONS, halogens. Second one is carbon tetrachloride, or it's called CTC, carbon tetrachloride. Third is hydrochlorofluorocarbons, HCFC. Fourth one is methyl chloroform. I think so you might have heard about chloroform. Methyl chloroform. Fifth one is methyl bromide. These are the major ozone depleting substances, of which 80% is depleted of the ozone is depleted by chlorofluorocarbons. Okay. Chlorofluorocarbons are different from hydrochlorofluorocarbons, CFC, HCFC. Okay. Where are they found? These substances are found in vehicular emissions, that is, vehicle exhaust, byproducts of industrial processes, aerosols, refrigerators or refrigerants. All these ozone depleting substances remain stable in the lower atmospheric region, but as they reach the stratosphere, they get exposed to ultraviolet rays. This leads to the breaking down and release of chlorine free radicals. These atoms, chlorine free radical atoms, are released, which react with the ozone gas, thus leading to the depletion of ozone layer. All these ozone depleting substances, they interact and they break down and they release the chlorine free radicals. These chlorine free radicals interact with the ozone and they deplete the ozone. Okay, Then what are the impacts of this ozone depletion on human beings and other life forms on the planet Earth? The depletion of ozone layer allows the entry of short wavelength harmful UV rays. You have to remember this for your prelims as well. The ozone depletion allows the entry of short wavelength harmful UV rays. Short wavelength harmful UV rays. What is it? Short wavelength harmful UV rays from the sun into the Earth's lower atmosphere. The harmful UV rays are associated with a number of health related and other environmental issues. What are these UV rays? These are short wavelength harmful UV rays. The exposure to UV rays from the sun can lead to increased risk of developing several types of skin cancers. The most common cancer caused by exposure to UV rays are malignant melanoma. I'll spell it. Malignant, which is called bad. The meaning of malignant is bad. MALIGNANT. Malignant melanoma. What is melanin? Yes, melanoma. Malignant melanoma is caused by exposure to short wavelength harmful UV rays. Okay. Not only this, it also causes basal and squamous cell carcinoma. Squamous, I'll spell it for you. SQUAMOUSA cell CALL cell carcinoma CARCINOMA. So these are caused when any person or anybody is exposed to harmful short wavelength UV rays. What do they cause? They cause malignant melanoma, basal, basal, and squamous cell carcinoma. UV rays also harm the human eyes. Direct exposure to UV rays can lead to cataract problems and also photokeratitis or snow blindness. Photokeratitis, PHOTOKERATITIS, or it is also called snow blindness. So when exposed to UV rays, they also impact the human eyes. They might lead to cataract problems or snow blindness. The human immune system is also highly vulnerable to UV rays. Increased exposure to UV rays can lead to weakening of the responses of the immune system and even impairment of the immune system in extreme cases. The exposure to UV rays can lead to acceleration of the aging process of the skin. It can also lead to photoallergy that results in outbreak of rashes, especially in fair-skinned people. In humans, exposure to UV rays can also lead to difficulty in breathing, chest pain, throat irritation, can even lead to hampering of lung functioning. Apart from humans, UV rays also affect other life forms too. It adversely affects the different species of amphibians and is one of the prime reasons for the declining number of amphibian species. What are amphibians? You might know this. It affects them in every stage of their life cycle, from hampering the growth and development in larva stage, results in deformities, decreasing immunity in some species, and even retinal damage, that is eye damage, and in some cases they cause blindness to some species. UV rays also have adverse effects on the marine ecosystem. It adversely affects the planktons, which play a vital role in the food chain and ocean carbon cycle. The affected phytoplankton will in turn affect the whole ocean ecosystem, because most of the organisms feed on this phytoplankton. UV rays will also affect the plants. UV radiations can alter the time of flowering in some plant species. It also can directly affect the plant growth by altering the physiological and developmental processes of the plant. So these are the impacts of the ozone depletion. I'll repeat. In human beings, it causes several cancer. What are those? Malignant melanoma, basal, squamous cell carcinoma. It also causes blindness or snow blindness or cataract problems. It impacts the immune system. It affects the lungs. It accelerates the aging process of the skin. It causes difficulty in breathing, chest pain, throat irritation. Apart from that, it impacts amphibians. It affects them in every stage of the life cycle. It might cause deformities or impact or hamper the development of larval stage, decrease immunity in amphibians. In marine ecosystem, it affects the phytoplanktons. Once the phytoplanktons are affected, the whole ecosystem is disturbed, the whole ocean ecosystem is disturbed. And it also, UV rays also, the short wavelength harmful UV rays also affect plants. They alter the time of flowering of the plants. The time of flowering might be reduced or increased in plant species. It also can directly impact the physiological and development process of the plants. So these are the impacts of ozone depletion on humans and other life forms on the planet Earth. Now let's go to the next topic, that is acid rains. What are acid rains? Acid rain is a rain. What is acid? Acid rain is rain with a pH of its water measured 4 to 5 or less than that. So pH which is less than 5. If the rainwater is with a pH of 4 to 5, that is called acid rain. Acid rains are considered as a fallout of industrial revolution. That means industrial revolution is considered as a cause for acid rains. It is a rain consisting of water droplets that are unusually acidic because of the atmospheric pollution. Acid rains have been recorded both in developed countries and developing countries. The northeastern USA, southern Canada, much of Europe, including Sweden, Norway, Germany, have recorded the acid rains continuously. In addition, parts of South Asia, Sri Lanka, Africa, southern India are in danger of being impacted by acid rains in the future. Acid rains was first discovered by a Scottish chemist, Robert Angus Smith, in 1852. Even before the First War of Independence, even before 1857. In 1852, Scottish chemist Robert Angus discovered the acid rain. He discovered the relationship between acid rains and the atmospheric pollution in Manchester. Where is Manchester? Manchester is in England. Manchester is also called the textile capital of United Kingdom. But this phenomena did not gain significant public attention until 1960s. After 100 years, it got attention. The term acid rain became prominent in 1972. The term acid rain is also called acid deposition. So in your exam, if they ask about acid deposition, you have to write about acid rain. What does this acid deposition or acid rain refers to? It refers to a mixture of wet and dry deposition from the atmosphere containing higher than normal amounts of nitric or sulfuric acids. The causes of acid rains result from both natural sources such as volcanoes. Yes, volcanoes also can result in acid rains, and even decay in vegetation, as well as man-made sources that primarily include emissions of sulfur dioxide and nitrogen oxides. So what are the causes of acid rain? Natural resources such as volcanoes, decay in vegetation. Other one is man-made emissions, primarily include sulfur dioxide and nitrogen oxides. 60% of the acid rains are caused by SO2. The sources of SO2 are thermal power plants, oil refineries, vehicle emissions, and some industrial processes. The sulfur dioxide is highly unstable and gets oxidized to sulfur trioxide. This in turn reacts with moisture to form acidic sulfate, and that comes down as acid rain. What is SO2 is the major cause? How does it get mixed up and becomes acid or the acid rain? This is sulfur dioxide is highly unstable and get oxidized as sulfur dioxide becomes trioxide. Sulfur dioxide becomes sulfur trioxide because it's unstable. Then it reacts with the moisture. This sulfur trioxide reacts with the moisture and forms acid sulfate, and this acid sulfate comes down to earth as acid rain. So what are the sources for SO2? Yeah, our thermal power plants where coal is used, and our cars, bikes, that is vehicular pollution or the vehicular exhaust, and then oil refineries as well. So sulfur dioxide contributes 60% of the acid rains. The next 40% of the remaining is caused by nitrogen oxide, that is NO. The sources are the production and consumption of nitrogenous fertilizers and explosives. Recently there is a bomb blast in Beirut because of ammonium nitrate. So, and it is also, these nitrates are also used as fertilizers. So this is cause for this nitrogen oxide occupies 40% share in the causation of acid rains. Okay, what are the sources of this nitrogenous oxide? Are nitrogenous fertilizers and explosives. These nitrogen oxides react with volatile hydrocarbons in the presence of sunlight, and they produce secondary pollutants like ozone, hydrochloric acid, carbonic acid, and also some extent causes acid rains. So this nitrogen oxide, which is volatile, these nitrogen oxides, they react with volatile hydrocarbons in the presence of sunlight, and they become secondary pollutants. It might become which one? This nitrogen oxide, when reacted with volatile hydrocarbon, might become ozone, might become hydrochloric acid, or might become carbonic acid, and they are the cause for acid rains. Okay, now let's look at acid deposition types or acid rain types. One is wet deposition, two is dry deposition. Wet deposition, WET, wet deposition, refers to acidic rain, fog or snow. Acidic rain, fog, snow is the wet deposition. If the acid chemicals in the air are blown into areas where weather is wet, the acid particles can fall onto the ground in the form of rain, snow, fog, mist. This acidic water flows over and through the ground and affects variety of life forms. Then what is dry deposition? The phenomena of acid chemicals falling onto the ground by being incorporated into dust or smog in the areas where weather is dry. That is called dry deposition. You don't understand? I'll repeat. Acid chemicals falling onto the ground with dust or smog, that is dry deposition. This deposition sticks to the ground, buildings, homes, or our cars, bikes, or the glasses of the home, trees. The dry deposition can be washed from the surfaces by rain, storms, leading to acidic surface runoff. This runoff water makes many water bodies more acidic. This was observed in cities like Mumbai, Kolkata, all these places. Okay, what are the impacts of acid rains on human beings and other life forms? Acid rains are bound to have damaging effect on the humans and other living organisms. Even the non-living components are also affected by the acid rains. Acid rains lower the pH of water bodies, thereby gradually turning the water acidic. The impact will be very severe on the lentic ecosystems like lakes, ponds, and tanks. Number 2. Now the second impact of acid rains. Decline in the pH value of the water results in immediate death of many young fish, and at the same time affecting reproductive maturity of the adult fish. This further leads to turning such water bodies into fish graveyards. Third impact. The dead fish further add to the organic matter of the water bodies, leading to increased decomposing activity. Such water bodies even experience algal blooms, making the water unfit for human, agriculture, animal, and industrial uses. The fish die, and this dead fish becomes the organic matter, and the water bodies, it leads to increased decomposing activity, and there in such bodies there will be a increase in the algal blooms, and thus this particular water becomes unfit for humans, for agriculture, for animals and industrial uses. That is the third impact. First one is the water becomes acidic, second one is it declines the pH and also affects, and young fish are dead, and it affects the reproductive maturity of the adult fish. Third one is algal blooms. Fourth impact of this acid rains on humans and other organisms. Acid rains accelerate the corrosion of metals. They accelerate the corrosion of alloys and hence pose danger to the huge steel structures. That is why they every year paint this Eiffel Tower in Paris. Okay, the fifth impact. Acid rains have degrading effects on the marble, turning into flakes of calcium sulfate. Such a degradation effect of acid rains on the marble is called stone leprosy. What is stone leprosy? Leprosy, Leprosy, stone leprosy. It is degrading effect of acid rains on the marble. Classic example of the stone leprosy is iconic Taj Mahal. It is affected by acid rains. What happens there? The marble turns into flakes of calcium sulfate because of acidic rains. Marble turns to calcium sulfate. That is, this phenomenon is called stone leprosy. Okay, the sixth impact. Acid rains even affect humans directly. The skin burns in acid rains and turns into yellow color due to the formation of pigment, that is xanthoprotein. So humans, it causes burns, skin burns. 7. Acid rains also increase the nitrate content of the water. The consumption of such water leads to nitrate poisoning, ultimately leading to anemic condition called methanohemoglobinemia. I'll spell it: methanohemoglobinemia. METHANOHEMOGLOBINEMIA. What is it? It's anemic condition because of nitrate poisoning. Methanohemoglobinemia. Okay. Eighth impact of acid rains. Acid rains also cause necrosis, fluorosis in the leaves of plants, leading to decreased crop yield. They cause necrosis and fluorosis in plants and thus reduce the crop yield. So let's recap. We have started with ozone layer depletion. We have discussed the importance of ozone layer, and then the substances. We discussed about ozone depleting substances. What are the ozone depleting substances? 80% is chlorofluorocarbon, that is CFC, and the rest are halogens, carbon tetrachloride, in short CTC, and the next is hydrochlorofluorocarbons, that is HCFC, and then methyl chloroform, methyl bromide. How are they released into the atmosphere? From vehicular emissions, byproducts of industrial process, aerosols, refrigerants. Next, we have discussed about impacts of ozone depletion on human beings. I hope you remember, that is, it causes cancer, cataract, impacts immune system, all these things. Next, we have discussed acid rains. The rain with pH of its water measured 4 to 5 or less than that is called acid. When was it discovered? In the year 1852 in Manchester, England, by a Scottish chemist, Robert Angus Smith. Okay, 60% of the acid rains are caused by, you reply in the comments below. 40% of the acid rains are caused by nitrogen oxide. What are the types of acid deposition or acid rain? Wet deposition and dry deposition. Excellent. And lastly, we have discussed the possible impacts of acid rains on human beings. What is stone leprosy and what is the classic example of stone leprosy? You reply in the comments below. Apart from this nitrate poisoning leads to anemic condition in human beings, that is methanohemoglobinemia. Okay, with this we'll end our today's lecture. Thank you for listening. If you have any doubts, queries, you can mail us to beiasacademy@gmail.com. Thank you for listening. Have a great day.